Good morning, everyone, and thank you for joining us. My name is Francesco Pagliarello with Viavi Solution Sales. I want to thank you for joining our call today on controlling your radio test set remotely. We have a lot to share with you. But before we begin, this webinar is being recorded and will be available for you to review or share with your teams in approximately 24-48 hours. We'll send an email to all attendees with a link with the recorded version. All lines are on mute, but we are monitoring the chat and will answer questions at the end of the webinar or reach out to you individually to ensure you get the answers you seek. The question will be anonymous. And now I would like to turn it over to our speaker today, Barry Hack. Barry.
Thank you, Francesco. Thank you. Good morning, everyone. Maybe it's good afternoon for some people I see on here. Thank you for joining. It looks like my bug I've had in every session is still here, where it drops out of full screen. I apologize if it does that several times during the call. I still haven't worked out what's causing that. So some of you hopefully have been on a number of these webinars already, and the one today is going to focus on just an introduction to remote control of your test set, and you may do that for a number of reasons. But we'll just start with a few generic, shall we say, company slides, if I may. These are the 5, shall we say, technical specialists we have around the world. 3 in the US, 1 in Singapore, and myself in Europe. So just to highlight, obviously, if you guys are from APAC, you can go to Mohammed. If anyone's from the Americas, you can go to Dave, Michael, Bill. But obviously you have your sales guys from Viavi and also your our distribution partners to talk to. But for Europe, Middle East, Africa, it's myself on the technical side. Okay. Just a very brief overview. I haven't left the slides in for the whole of Viavi. Viavi is a multi-billion-dollar company, famous probably as JDSU, Wunderlich & Goltermann, and historically their focus was on cable and fiber testing. But the slide here, this is really looking at the company in terms of the radio test set side of the business. So you'll actually see that Wunderlich & Goltermann, JDSU up at the top there, they had some capabilities, but most of the test set capabilities have come from Marconi Instruments and IFR historically. So you'll see, as you look down the left side, some of those company names. So Marconi, IFR, Aeroflex, Wiltec, Cobham, and then through into Viavi. So today, what are we going to talk about? We're going to talk about remote control of the radio test sets, okay? And it's going to be fairly basic because of the time frame we have. We only have 1 hour, and I do want to try and leave some time for questions. That's always good. But why do people want to use remote control? So we'll have a look at using remote control rather than just pushing buttons on the front panel. And we'll also touch on the pros and cons, so the benefits and the downside of using remote control versus the auto test capability. We'll look at how to set up the test environment to benefit from the remote control, and there's several ways to do this. We'll touch on maintaining security. Of course, if you have a remote control connection, you may be going out into the wide world of the internet. Got to consider security, especially these days of cyber issues, shall we say. We'll look at running remote applications, and I'm going to be touching on probably both 3920B and the 8800SX today. But just to note at the bottom there, the 3550R, which is the handheld test set, broadly shares the same remote command set as the 8800SX. That they're based on the same hardware platform. But also bear in mind the 8800SX does have some additional capability that you will not find on the 3550R. So of course those remote commands won't work with the 3550R. And actually, when I talk about 8800SX, we can go back to the S version and the plain 8800. when I talk about 3920B, we can go back to a 3920, even back to 3901, 3902. So the big question, why do we use remote control? And usually it's any time it becomes efficient to migrate to remote control or automated measurements. Okay. We'll go through a few of these examples, but they don't always happen. Why? Sometimes it can cost more to automate something than it does to have a person pushing the buttons. If I pick on China as a good example, there's a lot of automation in China, but there's also a lot of factories that are very, shall we say, manually intensive. In the Western world, that would all be automated, but again, labor cost versus solution cost, shall we say, for automation can vary widely across the world. So always bear that in mind as well. So one good example, we have a radio workshop, maybe who are selling PMR radios, fixing radios. Could be an avionics workshop, could be a military repair center for military radios. We have multiple users with multiple radio test sets and multiple radio types. And by using remote control and some automation, you could make that a lot easier for the users. Especially if you have many different radio types, they could plug in the radio. You could tell it what type of radio, and it will automatically select the correct tests or the correct test sequence for you. Okay. Again, if you've got 20 users all using 8800 SX, which I've seen in one workshop, they're all pushing buttons manually. Again, to make it efficient, you automate one test set, and then rapidly, you know, within minutes, effectively, you've automated all 20 test sets. You just share that program or that capability across all the users. If you're doing repetitive tests, so it can be the same radio type many times. Again, when you have repetition, that's where automation can be very useful in terms of becoming more efficient. Oops. I apologize, my little gremlin is back with me. So again, two different scenarios there within radio workshops. Another example might be where the radio test set is placed in a remote location. So for example, you might want to place a radio test set at a cell site on the side of a hill. You're looking at an issue with the base radios, you're looking at an issue with interference. It may be very cold, winter in Norway, it may be very hot, you know, summer in Saudi Arabia. You don't want to actually be sitting there with the test set in those conditions if it's an issue that's going to take time, which could be you know, minutes, hours, days. I've seen people leave test sets on in a cell tower environment, safely locked away inside, you know, the secure compound, monitoring, you know, signal strength, monitoring for interference. That can be days or even weeks. You do not want to be sitting there 24/7 looking at that test set. Okay, so you can take it away, leave the test set there and take yourself away back to a nice, warm, comfortable office or home office. And as I mentioned there, the other thing is you might want to monitor spectrum or channel monitoring over time. So you could log the received power over a number of channels. You could look at a particular channel and have a program that triggers you know, an email response, an alarm, if you see something in the spectrum that you either don't like or shouldn't be there, or it's a signal of interest. You might even do some simple drive testing. You could just drive around, do some measurements, and you could type into the computer the location. It could be, you know, via RV Stevenage, via RV Edinburgh, via RV Newbury in the UK, and you've done some measurements just in those local areas. But again, there's nothing to stop you hooking in a GPS into your system. There's plenty of low-cost USB GPS modules out there that you can use, again, to do a very basic drive test. We have better solutions for that, but it would give you some basic capability. I'm hoping everyone who's on this call today has either seen, used, or aware of the auto test capability we have. that allows us to do automatic test and alignment of radios. And these are options on the test sets. But we're supporting things like Motorola, Kenwood, ICOM, Tate, Harris, just to name a few, where we work with the manufacturers to provide those auto tests. What you don't tend to find in the auto test, though, is capability for maybe older legacy radios like analog AM and FM radios. And again, there's many of those being used. So you might want to use some sort of remote control to do your own sort of automatic testing or guided measurements, guided testing. You may have a proprietary radio system that we don't support. I've seen phase modulated radios. We don't have phase modulation capability on the test sets, but if you use a 1 kilohertz test tone, your phase modulation, suddenly you can decode that using FM. Or we can apply a known FM signal as a test signal, and the radio will see that as a phase modulated signal. So there's tricks you can play in with test signals that you couldn't play in a proprietary radio system with live signals. You might want to test base radios. Again, we have some auto test capability for Tetra base stations, for example. But you may have your own analog base stations. You may have your own repeaters. You may have something with POCSAG paging. Any of those things, we provide, the capability to use remote control to do something that's going to save you a lot of time, especially when you're doing multiple base stations, multiple radios. And you may have classified radios, so you don't want to tell us, that they're FM radios or they're P25 encrypted radios, or they're actually some generic modulation. You want to keep that to yourself and keep that information very closely guarded, not to be released even to the test set supplier. And as long as the test set capability allows you to do the testing, again, you can provide some sort of automation yourself. The other thing with the remote control is if you look at our auto test scripts, they follow a sequence that typically is given to us by the manufacturer. So they will tell us you will do these tests with these test parameters, these test scenarios, and these are your test limits for pass-fail. Okay, and they're very, very comprehensive tests. They approved by the manufacturers. They do a lot of testing of the analog or the digital side of the radio. They can tune the radio. We can test the radio. But you are then restrained or constrained by what is in that auto test script. If you wanted to do something different, using remote control might allow you to do that. Let's say you wanted to do bit error rate measurements on a radio. We do the measurements out at maybe 1 power level, close to sensitivity. Could be minus 115 dBm. You might decide that in a workshop or even in R&D, you want to test minus 115, 116, 117, 118, and keep going down, just so you can actually build a graphical curve that shows received signal strength versus bit error rate, or if it's analog, received signal strength versus SINAD measurement, for example. Okay, so you wouldn't necessarily have that in the auto test script, but you would be able to do that using the remote control commands. Of course, Autotest does have benefits. As I say, it is fully supported by us. So once you buy it, we maintain that script as the manufacturers change the firmware or the capabilities in the radios. It's compliant to the OEM manufacturer's needs for test and alignment, and it's approved by the OEM. Okay, if you write it yourself, it's your program that you maintain, and it is approved by yourself. Okay, and of course you may even be an OEM yourself. So how to set up the test environment? Well, there's a number of factors we have to look at. The first one is, which programming language are you using? Okay. Are you using Microsoft, C#, C++? I used to use Visual Basic. Are you using Python? That's very popular. Some people prefer to use NI LabVIEW or Lab Windows CVI, those types of applications. And there's obviously many other programming languages that you can use. Okay, so again, think about the language that you want to use first of all. And then you're going to need things like what's the IP address of the radio test set, and you can set it to a static IP or dynamic with a DHCP capability. You need to know which port to use for remote access. So when you connect to the test set, we define what the port will be for you. Okay. You need to consider things like firewalls, security, VPNs. Many times, for example, I've been asked to remote into a customer's unit, and you find you cannot access the unit because of their company firewall, their company security, etc. So you may have issues with things like that. You might want to consider the use of VPNs. So you've got a secure link to wherever you're connecting to. Okay. And then you've also got to consider how you're going to, or how your software is going to connect through, WinSock, for example, to the test set. So from your computer program, there's usually a middle layer of software. And I put two examples here, NIVisa and WinSock or Windows sockets. That's two examples where you go through that middle layer of software that then effectively lets you send the commands physically out over the Ethernet to the equipment. You also need to consider the computer hardware. You know, if it's a laptop, that's great. If you're doing a lot of work, say in base stations, you have a 4x4 truck, four-wheel drive truck. You're going up hills and then hiking up the last kilometer or the last mile up to the tower on top of the hill or the mountain, because you cannot always get vehicle access. You might want to use something like a Panasonic Toughbook rather than just a plain laptop. If you're based in a workshop or a factory or a home office, you might want to use a desktop computer. Okay, but you can also use things like the little small computers that are available today. You see these little cheap sort of Microsoft-based Windows 10 computers you can get to plug into your TV. You could use something like that. They cost like €100. You might want to use something like a Raspberry Pi. They're quite powerful now with the Pi 4, for example, and I'll touch on that again later. You also need to consider the operating system, and I've mentioned Windows and Linux here as two examples. So Windows I would use, which is what I'm going to focus on today. I'm using that on my laptop, but the Raspberry Pi, of course, would be a Linux environment. So again, consider the capabilities you have on those different operating systems and the drivers or the applications you need to be able to communicate with that external equipment. You've also got to connect from the computer to the radio test set. So I'm purely focusing today on Ethernet. That's what we have on the 8800SX 3550. The 3920B, we have Ethernet, but also there's GPIB and in fact, I think RS232. But they're what I will call legacy communication buses. We're going to use Ethernet. Why? Generally because it's cheap. An Ethernet cable is, €2. You can have a direct cable. Obviously, you can go across the internet or your intranet to the remote locations. And you can even use things like cellular to Ethernet modems. So you don't even have to have a remote site that has Ethernet capability. If you have cellular coverage, 3G, 4G coverage, 5G coverage, you can actually use cellular modems to maintain that connectivity to the test set. So as well as controlling the instrument with remote commands, the other thing we can do is we can show a remote front panel, which is basically the screen of the test set appearing on our computer. And that's really useful because if you're trying to write some sort of application with remote control commands, and you're not sitting next to the test set, you can start doing your programming, but you can actually watch what the test set is doing by looking at the VNC window. Equally, within the VNC window, you can actually remote control the unit effectively by using your laptop as a remote front panel. Okay, so it's almost like manual control, but you're doing it remotely. Okay, and while we're running the VNC connection, the virtual network connection, or the virtual front panel, we can also be running the remote commands in an application, and we can actually also be doing file transfer if we want to do that. Okay. So we've got to consider these days cybersecurity. Now, for a lot of people, if you're working, let's say, for example, with VHF or UHF PMR radios, you know, if someone was to sniff your Ethernet connection, and assuming they understood it was a VNC connection, maybe they could tap into that and see what your test set is doing. General PMR activities, it's probably not such a big deal. Okay, but if you're working with critical infrastructure, you know, electricity, gas, oil, those types of systems, if you're working on a mining facility, a big mining facility, a chemical plant, the Panama Canal would be another example in Panama. All these types of environments, you need a lot of security, because you always have people that are trying to maybe access your system, to monitor it, to try and install viruses. So again, anywhere you have a connection back to your computer, if it's a company computer, you may have potential cyber risks that you need to consider. Okay, so you might want to consider using, for example, SSH tunneling, so a secure tunnel, or a VPN, or things like for file transfer we can use. Can I apologize for my gremlin? We can use WinSCP or Secure FTP for file transfer of files or screenshots from the test sets or to the test sets. So think about those methods as well. They may be something you need. They may be something that doesn't really concern you. And obviously, if you have a direct cable connection within a workshop or an office, you're localized anyway, so you don't really have that security risk. We do have a little vial of what we call QuickCard, which talks about how to set up that VNC connection through a secure SSH tunnel. Again, if that's of interest to you, please mention that in the question and answer box, or contact myself, Hamish, or Francesco, who are on the call today. Okay, so the QuickCard is quite useful. It literally guides you through how to set up that SSH tunneling whilst you're doing this remote control. Okay. And what I've always found when you're inside a company intranet is most of the security issues are the computer, not the radio test set. Okay. However, what you'll find is the IT department are happy they can take, or mitigate the risks on your computers. What they're not so sure about often is how they mitigate the risks of the test equipment, which of course has a computer inside. So quite often you'll have IT policies that say, third-party equipment is forbidden on your network or intranet. But you may be able to ask them for an isolated IP address. You may be able to even ask them to route a particular port that I could access, for example, through an isolated IP address into your equipment. So I could come in from outside into your test set, and that test set is basically isolated from the rest of your company intranet. Okay, not something I could do myself, but I would ask our IT department to set that up. So again, consider all of these security issues. So let's have a look at some examples of remote applications. For most of these, I'm just talking about them. A couple of them, I'll show you live things, and one or two of them I have videos. Videos are not always the same as showing it live, because I think they take some of the effect away of the presentation. However, I've seen many live presentations go badly wrong when something happens with that connection or the equipment. Okay, not just with test instruments like this, all sorts of webinars. But let's start with the VNC software. So this provides us with a remote front panel. Control is bidirectional, so I can change things on my laptop in a moment and it will change on the radio test set, or I can touch things, buttons on the radio test set, and they will change on the laptop. That's quite powerful, okay? Because as well as me remote controlling the unit, I can actually see what someone's doing with the unit. So if a customer was using the unit and they had a problem, I could watch what they're doing and then show them what they're doing wrong. Or I could watch what they're doing and understand the problem with a particular radio, the issues they're seeing. Or, as I've done before, I've had test sets in one country with a customer. I've been in another country, maybe doing a demonstration or training them, and I've had people from a third country watching who are part of that original company. So again, you can do remote training, you can do remote support, remote demonstrations, or you can actually watch what someone's doing with the actual front panel, watch that remotely. So, okay, I can see what you're doing wrong. Let me show you what you need to do. So again, it's a very powerful tool for many different scenarios. One point of note, the 8800SX will accept one VNC connection. That's usually enough. You have one person controlling the equipment. Interestingly, on the 3920B, we can accept 10 connections. So we can actually have 10 people all hooking into the unit over Ethernet. The problem you have with that is if 2 people try and control the unit, then crazy things can start to happen. One person is trying to control something, someone else is playing with something else, and it's not working as the first person expected. So you can do that. It saves you having to go through maybe a web conferencing facility like we're using today. You could just use a telephone call to multiple users, and they could all actually remote into the test equipment. But it can cause issues, like I say, if multiple people try to run the test set at the same time. This is what the VNC software may look like. We tend to recommend Type VNC. Seems to be the most effective with our test sets. There's also Ultra VNC, there's VNC Viewer, there's other capabilities. In fact, I've used all of them. But the one we tend to recommend if anyone asks is called Type VNC. Most of these are free of charge on the internet. Some are chargeable. But basically, you start the software, you put in the remote host, so the IP address of the test set, and if it's an 8800, you're straight into the equipment. If it's a 3920B or that family of instruments, it will ask you for a password. And the password is simply 3900. But you do have the capability to change that password, that default password, actually on the 3920B. Okay. Now, what I just put up on the screen now is 2 screenshots. One is my VNC connection to an 8800SX, and one is the VNC connection to the 3920B. These are both running at the same time. So again, I can have multiple instances of Type VNC, and I can control multiple radio test sets at the same time. So each Type VNC connection is controlling one test set. So that can be quite useful as well. You may have someone with an issue with a 3920, and we may have the 8800 there just to confirm, is it the test set that has a problem, or is it the radio? Or we may be looking at something off air, is it the radio or the off air signal that has the problem? So sometimes having 2 effectively independent pieces of equipment, if you're looking at trying to bug find something, is it my equipment? Is it my setup? Is it the signal of interest? We can start to knock out each of those 3 possibilities, and then bring it down to the one that's causing the problem. Okay. You'll see VNC running later when I get to the live session at the end. So let's now look at actual physical remote control of the unit using remote commands. And one of the most simple things we can do is use the PuTTY application, which is a simple communication tool. Excuse me. So I might use PuTTY, for example, to do some very simple remote control, or what I might do is use it to debug commands. So if I'm trying to set up a test sequence for the radio test set, excuse me, I can start with PuTTY and just type in individual commands or queries and use the VNC software or have the test set in front of me and see what physically happens on the test set. If you're going to do that, or if you're going to do any remote commands, you probably want to make sure you've got the remote programming manual. So again, on the VIAVI website, you go to any of the radio test sets, you'll see what we call the RCI manual, remote command interface manual. And inside there, you will have all of the commands, whether they are commands to make the test set do something in terms of changing a parameter, or whether they're query commands, i.e., what is the power level, what is the current modulation setting, what is the SINAD value. All of those are listed in the manuals, typically with examples. And those manuals will be something like, between 100 and 200 pages, maybe more. So very detailed, all indexed. So you'll start with the manual basically to send those or to find those commands that you want to use. Okay, so here's a screenshot of PuTTY. So again, in here, I've put in the IP address of my test set. Okay, remember for the 8800, the port for remote communication is 9991. And I'm actually using a Telnet connection here. You do get multiple types of connection, but I'm using a basic Telnet connection. Okay, and here's an example. This is effectively from yesterday. So you can see I've got the IP address here. I've opened the connection on the PuTTY window and it pops over to this window. And first of all, I've done very simple star IDing query, which is tell me your identity, and it gives me, it's an Aeroflex 8800 series. Here's my serial number. Here's my firmware version. Here's the date and time reported by the test set. Then I ask it, what is your RF generator frequency? And it tells me that in megahertz. Okay, 137.9705. I've then sent a command here where I've actually commanded it to a new frequency, 123.456. I've queried it again, and look, it is at 123.456. So I could be looking at the VNC window at the same time as this PuTTY window, and as I send these commands to change the frequency, I would see that change maybe over here on that VNC window. Okay, so let me just try, let's just see if I can share my whole, excuse me for a moment. Let's see if this works. So hopefully, I'm going to share the whole window now. So at the moment, I have a couple of VNC windows open. Here are my two test sets. And Hamish and Francesco, if these are not showing, please shout.
I can confirm that they are showing. Hi.
Showing, excellent. Okay, thank you. This is the demo effect. This would normally come straight up. That's going to prove me wrong. Okay, so what I would have done here, I would have brought up that PuTTY session, connected through to my 8800. Oh, here we go. Sorry, the problem I have is running this and having the webinar control panel open, but no worries, we can get around this. So I'm in the office now, so I've got a different IP address than I had at home. I want to use Telnet, and remember, so it's defaulted to port 23. That is not going to work on my test set. If I remember correctly, that's the right one. Fantastic. So you can see there it's reported my test set. Now within PuTTY there, you see when it reported that it didn't do a new line and line feed carriage return. I can set that up in the PuTTY setup to include those. I haven't done it here, but maybe what I want to do now is, let me just go back down here so I remember the command, as it's always different on every test set. So let me just want to go :gen :freq. Okay. Okay, now I've hidden my, so it's :gen :frequency. So this is exactly what I did yesterday. And you see it's reported back 446, and that's in megahertz. :gen :frequency. So now I'm going to command it to go to, hopefully, 999.999 megahertz. And you see up here now on the test set that that frequency has changed. And again, if I want to query that, it's the same command but with a question mark, and there's my frequency. So anything I can do on the front panel, typically I can do with remote commands. So for the generator, I could change the port from TR, I can change the generator level, I could change the units, I can enable it on and off. If I expand this, I could put a cable offset in here. Okay, I could turn on the 0.1 dB step capability. So anything I'm doing manually on the front panel or with the VNC software, I can do that in the PuTTY software or the remote control. And just while we're here, just to show you, I'm actually now controlling the test set manually, and you see it's showing up here on the VNC window over here. Okay. So that's a very quick demo of the PuTTY software. Okay, so I'm going to jump back to the presentation now. So my next application is using Python and what I call a guided measurement. So this is not controlling the radio, this is only controlling the test set. So the version I show you here is a cut down version because I don't necessarily want to tell you which customer this is for, but it's for an international airport for them to test their little ICOM portables and mobiles, so the ground radios. Okay, so this is used by their engineering team, maintenance team around the airport, baggage handlers, etc. And obviously through to the control tower, and then that also can be relayed back to the pilots. So if there's an issue on the ground and someone is taxiing, you don't want that plane taxiing if someone's dropped some, some baggage on the taxiway somewhere. So they wanted to check the radios, and a good reason for doing that was that there was an international air show, and they were happy with their safety record. They were happy with their site security at the airport. But for some of the air shows, for example, the example in this case, the Americans wanted to see risk assessments. They wanted to know about all their security capability around the airport. It was a commercial airport. They wanted to know about all their maintenance, has everything been maintained? And they even wanted to know that all of their radios had been tested. And when those US air safety team came in and saw the results from these test reports, they were very, very impressed. They said, wow, we haven't seen this before. How have you done this? And we worked with this guy at Viavi. It was quite easy to do it, and we've tested all our radios and his test reports for all of them. So this is not an automatic or an auto test script that we provide as a costed option. This is something that the customer can do themselves to help them automate their radio testing. Again, it's repetitive testing, maybe 100 radios, and importantly, it's having that documented report that isn't a guy just writing numbers on a piece of paper. Because if you write numbers on a piece of paper, sometimes the wrong number may be written down. I've even seen examples both in radio workshops and national, shall we say, public security networks. I've seen handwritten documentation that has not been legitimate. So by automating that, you take away some of that risk and some of that human error in some cases. So we have a little script, we can put limits on it. I didn't enable the limits in this case. We have some commands that we're sending to the radio test set. And if you can see in the gray, SINAD, DMOD, reading, average, query. So we're asking for a SINAD reading on the demodulated RF. So this will be transmitter SINAD. And we're asking for the average reading rather than the peak, for example. And then we'll format that and we'll provide a test report. So hopefully I've blocked out the airport that wanted this. But we have a radio serial number. We have information about the test set. For QA purposes, we need to know the serial number. We also log time and date, of course. And we do some simple measurements on the radio. We should be getting between 80 and 85% AM depth. We've got good distortion. We've got good SINAD. We've got good power. And on the receive side, again, SINAD is better than 12 dBs. Okay. So tick the box, that radio is good. And this is what the US air safety team wanted to see. And without this, they would not have US, commercial or military aircraft flying into that air display. Oh. To show that quickly as a video, and I'm going to skip through a bit of this because at the start we're just you see at the bottom, I'm just going to run a Python script. I'm going to preset the test set so I know where I'm starting from. Okay, but I'm jumping through here. I've set up my equipment to an airband type frequency for my demonstration. And you can see here in the script, we've got transmitter measurements. We actually then tell the user to key the radio on the user's version of this. And we can do the measurements here, including CTCSS, so we can show that 67 Hertz tone, for example. Okay. But you'll get this in the copy of the presentation afterwards. Another example is LabVIEW. So again, we worked out the commands that we needed. We just wrote this down in a table in a Word document. So first of all, debug the command sequence that we need. Make sure we know what delays we need in there. We may need, 100 millisecond delay if we're asking a query. We may need some seconds if we're changing systems, or if we're resetting the unit back to defaults. So again, you need to sort of work those out first of all, is the easiest way to do it. Then you write your program. Again, this is a very generic version of the program because I can't show you who the customer is. But in here, you see we have some commands where we're setting, the frequency, the level. Then we're querying that frequency and level, but we're also querying the AF frequency, the FM deviation, for example, the audio level, and the external audio in SINAD. Now, those two last readings, we didn't have anything connected, so those numbers are very low. But you can actually see real numbers. Again, a 67 Hertz CTCSS tone in here, just used for the demonstration. On the customer's final version, we put in their radio test frequencies, any digital coded squelch, any DTMF tones, whatever they want, we can embed that within the script. Or of course, in this case, we give them the skeleton script. They've got a LabVIEW expert. He then takes over. We've just shown him how to communicate with the test set. He writes the rest of the program. Another example was an airport that wanted to test ground-to-air radios, but they said, well, we can key the radio and we can listen on the receiver, but could you actually control the radio as well? And this was quite an interesting one because the radios themselves are controlled, as in the ground to air radios in the control tower, they're controlled using an IP connection and voice over IP. So in the middle window here, what you actually see, we're sending a bunch of RS-232 commands to a telecoms tester. So what this telecoms tester would do would use G.703 protocol, and it would allow us to send control bits through to the radio to tell the radio what frequency to be on, or which channel, to key up, key down, and also over the voice over IP capability, we're sending a 1 kilohertz tone. So the test set can actually then demodulate that transmission and measure the transmitter power, deviation, and SINAD. We can then send an analog 1 kilohertz tone on a transmitted AM signal into that ground to air radio receiver. We receive that back over the voice over IP connection, and then the telecoms tester will turn that voice over IP digital 1 kilohertz back into analog into our test set, and again we can do a SINAD measurement. So we're actually using a piece of hardware in the middle to allow the voice over IP capability. Okay. And again, what we've used there is a third-party telecoms tester, but of course, one of the things Viavi historically has been famous for is their telecoms testers. So that capability we bring onto Viavi product as well. So it becomes a Viavi hardware solution. Okay. And that's showing then some of the commands for the test set as well. Almost finished with the examples, which is good for timing. Remember as well on 3920B we have auto test 2 capability. So inside the 3920, you do have access to the automatic test capability. Okay, and within that auto test capability, you do have the capability. Just like I used on the computer, I was controlling the telecoms tester in that last example via RS-232. You do have the capability to do that within the auto test 2 programming language on 3920B. There's either a direct RS-232 connection on the back, or how I tend to do it, I can use a USB to RS-232 converter. We even did one example with one USB port. We had a 16-way RS-232 converter, so we could control 15 radios and an RS-232 RF and audio switch matrix. So you can start doing some very clever things with the scripting, either internal to the box or external using Python or LabVIEW, for example. So again, I wrote a script inside the unit, and hopefully the little yellow star that popped up, this is for a, like I said, a radio which has commercial and military versions. And it has AM, FM, single sideband, and FSK capability to set up the radio from scratch, to set up the test set from scratch, and to do the transmit and receive measurements on one channel. You can see the test time there. So, you wouldn't even be able to push the buttons or recall a stored setting on the test set in the time it's taken me to configure the test set, configure the radio, and do all the measurements. And as well as configuring the radio, you can probably see on this right-hand window, and I've hidden some of these, it gives away who the radio belongs to. I'm even sucking out of the radio, serial numbers, firmware numbers, even the temperature of the power amplifier. Okay, so if I have those commands from the manufacturer, they all get implemented within the test script. Okay, I've done exactly the same capability here, but external using Python and the 8800SX. And just to finish on the examples, and I've picked on Raspberry Pi because I have a few of those. You could even stick a little touchscreen on top of the Raspberry Pi to make it self-contained. If you put it next to the 8800, you have some USB sockets on the back for power. It won't power a Raspberry Pi 4, but you could use a Pi Zero. You could use one of the earlier Raspberry Pis that use less power. Okay, you've got Ethernet on there. You could even connect a GPS device via USB, for example, and you could even control a radio using USB to RS-232. That might give you a simple drive testing system. You've now got, GPS positioning or GNS positioning, plus a radio test set giving you the power at different channels, or the could be DMR. You could be showing FSK error. You could be showing the color code on that channel that's being used. Okay. You could be static doing this, or like I say, you could be drive testing with a GNS puck. You could do a radio auto test like I showed you on the last example, control the radio as well as the test set. Okay, and again, you could put something at a site and, leaving a Raspberry Pi on a site, if someone breaks in and steals it, it's a Raspberry Pi. It's not a company laptop. So, okay, you might be considering how much did your test set cost that they've also stolen, but you don't lose a laptop that may have other confidential company information on it. Okay. Doesn't have to be a Raspberry Pi. It could be any of these little microcomputers that are available today, but very cheap, very cost effective for remote control. So I'm going to leave the live demos, but I have both test sets running at the moment. So if we have a few questions in the last few minutes, I will try and switch to them and maybe show you as much as I can. But remember, any questions you send in, we will try and answer now, or send you an email response afterwards. So on that, I'll stop the presentation. I'll throw it back over to Francesco and Hamish and see what questions we have.
Thank you, Barry. Yes, we have several questions. Okay, I can start reading some of them. The first one is, can I use this type of remote control with other equipment?
Yes, I mean, the generic control using Python and LabVIEW, yeah, you can use it with our equipment. We have legacy equipment. You can use it with competitors' equipment. Like I said, you can use it with these UPS, USB GNSS pucks, little mag mount ones that fit on the car roof, and they can be 25 euros. You can use it with third-party products. You can control radios, again, either via RS-232 or USB to RS-232 converters. One little trick with the little USB GPSs these days, ones I had 5 years ago that were just GPS, as in the American satellites, the format out of those GPS receivers is different to the modern ones. The modern ones that I have will run GPS, Galileo, GLONASS, and BeiDou. So I'm running Russian, Chinese, European, and American satellite systems. So you should get better coverage, better position fix. You've got 4 satellite systems all running against each other. But the format you get from that for the GPS or through the GNSS positioning is subtly different because you have those different satellite formations. And remember as well, if you're running GPS or GNSS systems, quite a big problem these days is jamming. There's a lot of jamming, quite often from transport, truck vehicles or taxis where people don't want their company or their boss to know where their vehicle is. They've stopped for an illegal break in a lay-by, or they've stopped at their girlfriend's house, or they've stopped outside a casino to do some gambling, so they might want to hide their position, and quite often it's become quite a big problem. There's a lot of jamming, and a lot of that happens at airports as well, and transport hubs. So consider that if you're using GPS. But yeah, you can use it with any equipment, obviously, where we support you with our equipment. Okay, so thanks for the question.
Next one is, can you provide example code to get me started with my own program?
My simple answer would be yes. Obviously, I need to talk to the other guys. We've got to be careful, because if we give someone example code, they don't get it working. Oh, Barry, it's your example code. Now you need to help me fix it and get it working. So again, we could put some examples out there. You'll even find examples on the web from other people. Radio Hams have done example code, I think. There are some in the UK. There are chat groups for radio workshops where they share information. They don't tend to share their problems. They don't want their competitors knowing they have problems. But things like this, they may share little applications that they've done. So again, yeah, first point of call, come to us, or whoever your local Viavi partner is, or sales guy. But you can also do searches on the internet as well. So again, thank you for the question.
Following up with this question, I have another one. Does Viavi offer a service to write a customized test program for me if I pay a fee?
Again, the answer to that is, I think, come back to the commercial guys like Francesco and Hamish, or the local Viavi guys that you work with, and discuss that with us. There's always opportunities to do things. You might find something you want we already have as an auto test option on one of the test sets, or it may be an application that we can supply to multiple users. Anything's possible for discussion. That's what I would say.
Okay, that was also my thinking. Mm-hmm. Now, another question, other two interesting questions. What radios can I test with an external program?
If you can test it manually, you can test it with an external program, to the point where the program may flash up a box that says, please turn the radio to channel 3 or channel 6, please set the radio to 123.456 megahertz. Please set the radio to FM, or please set it to AM lower sideband. It could prompt you through. So as long as you can test the radio manually, you're still doing that manually. You're just automating the setup of the test set and the measurements on the test set. Again, think about if you want to look at the power, the frequency error, the modulation, and the transmitter synad. That's 4 measurements. For the computer to do that for you, okay, so we've said to you, key the radio, you say okay, boom, we do the 4 measurements. It now says go to channel 7, key the radio, boom, we've done 4 measurements. Go to channel 9, do the 4 measurements. Okay, so you're actually speeding up taking the measurements, plus you're also putting them into a table, even if it's a plain text document, but you've now got formatted results rather than someone's written them on a piece of paper or typed them into a spreadsheet, which is where you can have that human error. They're tired, or they're trying to press a 9 and they've pressed 8 because they're looking at their buddy who's doing something else on the next bench. So automation not only speeds things up, it also takes away some of that human error, and also provides the efficiency of that formatting that you can then pull into a spreadsheet or a document if you want to.
Thank you, Barry. This looks like it has been done for me, for a guy like me. I have another question. Is it possible to automate the commissioning of base radios as a Tetra cell site?
Yes, it is, and I'm guessing that's probably coming from either someone who has a 3920 with the automatic test script, for example, for the Motorola MTS or the Airbus TB3 radios. And it could be that it's either, I'm guessing it's either someone who already has that, let's say for Motorola, and they'd like it for, I don't know, Rohill or DAM, they have another manufacturer they're working with. Or it could be someone who's seen it on the 3920B as a an auto test option, and they wow, I want that on my 8800, because that also has Tetra base station capability. Equally applies to P25. It could apply to DMR or NXDN repeaters. We do have DMR repeater auto test as well, some capabilities, but yeah, again, if you can control the base station from the computer, and I've done this with Tetra base stations, I have an RS-232 link into the base station. I can put the base station or the base radio into service mode. I can then put it into factory test mode. If I can do that over RS-232 or Ethernet, then sure, I could automate that into a program and control the test set and make that a complete closed loop commissioning test. So the simple answer is yes, it can be done. Again, it's the effort to do all that work and then debug it. It's not a trivial exercise. You'd think it would be, but it never ends up being a trivial exercise.
Thank you, Barry. I believe that we are at the end. Thank you, Barry, and thank you to you all for joining our webinar today. If you think of any more question or would like any further information, please reach out to Barry, Amish, or to myself. In any case, all the other questions which we have will be addressed individually. And I would like to highlight that we have a next webinar on the 5th of August, best practice for testing analog radios. And I wish you a very good day. Thank you very much for attending our webinar.
Thank you, everyone.